So I'm Dr. Andy Smallburn. I'm the director of the EPSRC Network Plus for the decarbonisation of heating and cooling. And we're running this series of webinars, which are happening broadly every month, looking at various challenges across the topic. For this month, we're delighted to welcome speakers who are leading research around consumer responses to decarbonisation and the development of district cooling networks. So we're grateful to both presenters for providing their time today. Professor Ostergaard is a professor in energy planning within the Department of Planning in Aalborg University in Denmark, and he'll present on the 4 generations of district cooling, a categorization of the development in district cooling from origin to future prospects. Yeah, Professor Ostergaard has worked within the field of energy planning since 1995 with a focus on the simulation of energy systems based on high penetrations of renewable energy sources, as well as on the design of renewable energy system scenarios. He's the program director of the MSc program in Sustainable Energy Planning and Management at Aalborg University and head of the study board of planning and surveying.
And I could actually have followed up on Garrett's presentation because I'm also working a lot with district heating. So I'm not just a cooling guy, I'm also a heating guy with plenty of experience in how to convert energy systems. So actually, while listening to Garrett's presentation, I couldn't help thinking that I could have added a little bit there also. So I put in just one slide about heating, because in Denmark, about 2/3 of all the houses in Denmark, they're heated by district heating or by heating networks, as Garrett called it. And we do it for 3 different reasons. The primary is cost. Secondly, it's climate, and thirdly, convenience. So let me just focus on the convenience aspect for a little while, because I think that links up to what Gary was talking about, because this is actually how we want to have the heating. We want to have a radiator, we want to have a thermostat, and we can control the temperature. And then we have 2 options. Either we can have our own boiler in the basement. This is a very old-fashioned one, or we can have 2 pipes entering into our basement. And of course, there can be some issues with getting these pipes installed, but you can actually make horizontal drillings if you don't want to dig up your entire garden or your entrance to your house or whichever. So convenience, that is actually a main issue for very many Danes in terms of district heating. But that was not what I was going to talk to you about today. But I will say that here, after we've had the Russian invasion of Ukraine, people are basically scrambling to get district heating if they are in an area where it's even remotely possible. And people there are on waiting lists to get into district heating for the cost issue and also for the convenience. So a little bit about district heating, but we can pick up on that later in the discussion if you want to dig into that a little bit further. But what I was asked to talk about was actually district cooling. And we wrote this paper, and it was published about a year ago, on district cooling, where I, together with some colleagues, we tried to look into the evolution of district cooling and tried to put it into some generations. And if any one of you would care to dig even further into it than I can do in this presentation, it's an open access. Normally these articles are pretty expensive to get access to if you're not from within academia, but this one is actually open access, so anyone can read it for free. So just Google my name and district cooling, and you'll find this article, and then you can read all the details. But I've tried to outline some of the main issues here with district cooling. So I will start chronologically from the very first district heating systems, and then I will look into how it has developed over time, and I will end with some of the future prospects of district cooling. So the agenda here for my presentation, some of the main features for these 4 generations of district cooling, some definitions regarding this. We've made what we think is a nice chart depicting the difference between these 4 generations. I'm looking into how much district heating do we actually have, how much do we have in Europe, and where is it developing, and then some final conclusions at the end. And then I'll also, of course, be happy to take any questions on this or from cooling, as mentioned. So we have to go across the pond for the first district cooling systems that were installed. They were installed in the US all the way back in 1889 in Denver, Colorado. At this time, it was pipeline refrigeration, meaning that you have a compressor somewhere that sends out a refrigerant, which is then evaporated at the site of consumption. And if you're not into cooling very much, when you have an evaporation of anything, basically, then you take a lot of heat away. And so this is actually a way to get cooling transported. So you transport something under pressure, which then evaporates, and then you take cooling out through that process. It's something that was firstly done in the foodstuff industry. It was very convenient. So as for the cooling system, it's also a convenience issue here. A 1-inch pipe could supply cooling for 4,000 cubic meters of cooling. So it's something that butchers and warehouses would do. There are a few quotes here. It's the oldest reference that I have ever used in a scientific paper. It's back from 1891. It's absolutely perfect. It's something that a butcher needs to use for only 1 week to make him feel that this was a point in time when it was a him. It could, of course, be a her now. Feel that he's rescued from one of the greatest evils of the butcher's business, named the price, trouble, labor, and dearth attendant upon handling natural ice. The alternative at this point in time would be a horse carriage coming with blocks of ice you would put into your storage, and then it would release, or rather, it would take up heat. On the other hand, it would also release moisture, and would not provide a very nice climate, nor for you as a worker or for the food stuff you're actually storing. And they would rather have the new district cooling system rather than having free ice, actually. So even if they would not have to pay for it. So this is the very first system, and this pretty much also came around the same time as we have some of the first district heating systems. So district heating systems, they also go back into the 19th century. But we don't have these systems any longer. They are outdated by now. Then moving into the second generation of district cooling, this is a matter of economy of scale, basically. We're moving away from the industry into commercial and public buildings to provide cooling for these ones. And at this point in time, we're talking about chilled water, which is being circulated. So you're producing chilled water and you send it out through insulated pipes into houses or into buildings, where you then have a heat exchanger, or it's also commonly called a substation, which kind of takes the cool out of the water and cools air and circulates air into building. So it is something that you started developing in the mid 20th century, and we have some large systems, La Défense in Paris, Tokyo, China, Middle East. So it's something which is actually still being developed. It's something that is still being used. So simply sending out chilled water into houses. Moving on to third generation district cooling. So now we're getting closer to today. It's still a matter of comfort mainly in big buildings, either commercial buildings, public institutions, etc., but also moving into dwellings, actually. And a main feature of this generation of cooling that is diversity, meaning rather than having one source of cooling, which would typically be a centrally located chiller, then you take various sources. You can have a heat recovery from, you can have combined heating and cooling networks where you're producing heating, and then at the same time you're actually typically also producing cooling, as you will be doing if you have a heat pump, basically. So that's one area where you can pick up some heat. It can also be some natural cooling, meaning you might have a lake or a stream or river with the low temperature water, where you can basically take some cooling out of. So you will start playing on a slightly larger keyboard now, different options for cooling. It is something that is mainly expanding in the somewhat colder countries, because in the colder countries you will have your heating demands, and as mentioned, when you have a heat pump producing heating, then you will also be producing cooling, and so you have this potential synergy. So we will see systems in Paris, Stockholm, Helsinki, Toronto, Geneva, and also places in North America. But it's a somewhat more energy efficient way of producing cooling, and one of the things that was also a driver for this phase of district heating, or phase of district cooling, that is the phasing out of CFC gases in private systems. So you have all these ozone depletion refrigerants, and if you can take them out of hundreds or thousands of individual installations and have only one large installation, you can have a basically professional capability of maintaining these systems, and you wouldn't rely on hundreds or thousands of commercial or private owners to basically control their systems. You'll take all these CFC gases out of those systems and put into some common systems. So here you would again simply be distributing cold water, which is fairly harmless in most cases. Moving on to fourth generation district cooling, and now we are into something we are still developing. It is installed in some places, but here the focus is very much on smart energy system integration. I did mention that when you're producing heating with the heat pump, you're producing cooling also, so there's a synergy there. But here it's more or less 100% based on that synergy. Very much on that part. Also some natural cooling if you have that. And again, it's a matter of sending cold water out to customers. So you take the complexity of most of the installations away from the customers. Basically, when you are simply circulating cold water, also means that you have the potential of changing the technology without interfering with all the different consumers. They don't have to care about basically where the cold water comes from. And if you, as a professional cooling system operator, if you see some benefits of installing some kind of new technology, or you have a new waste cold resource coming from somewhere, then you can connect to those cooling sources without basically disturbing or disrupting the individual consumers. So again, it is something that is mainly relevant in the colder countries where you have a heating demand because of basically the benefits that you have for integration with the heating sector. Some cases which are more advanced than the third generation, as I mentioned before, we have Herlin in the Netherlands, ETH, that's a technical university in Zurich, FGZ in Zurich, Stanford University, and a few Danish cases, Høje Taastrup and Kastrup, Saclay University in France. So it can even be an integration of decentralized heat pumps in buildings, maybe drawing on some semi-chilled water, and then trying to seek optimality. It might be operating with some technologies that the buildings already had, but now they have a better source for getting rid of the excess heat, thereby getting a better performance of your chillers in the individual buildings. So it can be a complex mixture, but it also provides some flexibility for the energy system, because it can be dependent on, for instance, the electricity price. If the electricity price is high, then you're using this technology. If it's low, then you're using another technology. So it's very much adapted to future systems where you have a lot of PV power and wind turbines, which both are technologies which typically have a very large effect on how the electricity prices are in the electricity system. So they have flexibility and can supply your cooling using different technologies which are optimal under different sets of circumstances. So a brief slide with the definitions of these four generations. I'm not going to go into detail with all of them to say that. So the first generation, that was the pipeline refrigeration system with refrigerant. So you're basically distributing something like a CFC gas. For the remainder, it's all water-based. We have the large compression chillers in the second generation. We have the diversity in the third generation. We have this improved sector integration with the prospects of being better able to integrate the variable renewable energy sources like PV and solar power, and for that matter, also solar heaters into the system in the fourth generation. So that was the first 15 minutes, simply describing these generations and some of the characteristics of the different generations. I spent my last time just talking a little bit about the prospects and where it's being applied and how large are the markets, etc. Except, of course, that I forgot that I had this overview slide, which basically encapsulates everything I said. You can also see the increasing level of complexity. You have more and more technologies feeding into the different systems, and you can see the energy efficiencies going up. We can see some temperature levels, how they are increasing over time, because you don't have to have such a cold temperature in more modern systems or well-insulated modern houses. And with that said, I will do the last 5 minutes as I just introduced. All right, so globally, district cooling, it's not a big surprise, but it's something that you have in the Arab world, Middle East, United Arab Emirates, Qatar, Bahrain, Kuwait, Saudi Arabia. And some of these systems, they are pretty massive. I mean, we are talking about capacities in excess of 1,000 megawatts. I mean, that is the size of a nuclear power station. That's big if you're not used to megawatts. US, China, Japan, Europe, we also have a lot of systems, but they're typically smaller. But the very large systems, they are in the Arab world. And of course, this is also where you clearly have a cooling demand, and also something that's going to increase in the future with global warming. So that's not going to make it any colder. So just one of my local cases, because here in Aalborg, we are placed up here in the northern part of Denmark. Our district heating company, they are actually looking into how they can supply district cooling in different areas. We have what is called City South, that's a big commercial district. We have NAU, that's a new Aalborg University hospital. So that's a very large point source of cooling. We have the university area. I assume you can read the Danish there. And then we have some various areas with either industry or with the public administration. So they've been out there identifying areas. We do have an issue because Danish district heating air systems, they have the expertise in distributing heating, and they pretty much have the expertise in distributing cooling, because it's very much the same technology. But under the Danish legislation, they're not allowed to engage in activities which are not of essential importance to their main business. So we have a legislative issue. But even though you may perceive Denmark as a cold country, it is definitely an area where there's a lot of development in district cooling. And also because we have this experience with district heating, so people are not scared by the thought of the word district put in front of some kind of a public utility. We did this survey. This is a few years ago, 10 years ago, but this shows district cooling systems in Europe. And you'll actually notice it's a bit funny. And even the UK, you're on this map because this is from 2011. You'll notice that district cooling, it's more prevalent in Sweden, for instance, than it is in Italy. Again, it's not necessarily because Sweden is decidedly warmer than Italy, which it is not, but it is because they basically have experience with communal systems like district heating systems. So for them, it's not such a big issue to, hey, let's go make a district cooling system. Whereas in Italy, where they don't have anything like that. Well, they do have a little bit of district heating in some places. The switch, the transition, the transaction cost, and I'm not talking about economic cost, I'm more talking about the mental cost is probably larger because you don't really have any institutions, organizations who can handle it. So the funny thing is that we have a lot of district cooling in Europe, but it's there's a tendency that it's in the northern area. You also have some systems in Spain and Portugal and also in southern France, but it's more prevalent in the Netherlands and Sweden and even some in the UK. This shows how district cooling has been developing in a few countries. Now I have to move all the photos because I can't see my legend. All right, yes, that's better. So Japan started early with district cooling and has now reached kind of a saturation point, not much development. Sweden, they also started relatively early and then also kind of reached the saturation point. And this saturation point, of course, is due to the fact that in these countries, it is mainly commercial buildings. I mean, you don't have private houses in Denmark with cooling unless you're really a billionaire who is very spoiled. No one else will have cooling. So it is for commercial buildings with a lot of equipment basically heating up the building. But we do have some areas where you see that you have not reached the saturation point, like Finland is moving ahead pretty much. Germany, there's not a lot of development. Unfortunately, we don't have this data for other parts of the world. So this is just where we happen to be able to find this kind of data. Just to compare it briefly to district heating, you can see that this is district heating versus district cooling in the EU 27. And we have a district heating supply of 13% of the 9,200 petajoule of heating demand in Europe, basically, whereas district cooling, that is a mere 1.6% out of about 700 petajoules of cold. So the heating demand in Europe is something like, I should say, 12 times larger than the cooling demand, but also the penetration of district heating, that is way higher than it is of district cooling. So ideally, there should be a large development potential for cooling or district cooling in Europe. And then there are some further numbers here, which is not essential for you to dig into. This is just one of my final slides, just showing what does it look like when you are installing district cooling in the Middle East. This is a district cooling pipe, and you compare it by the workers you see there standing in the trench, and they're pretty big. So some of these pipes can be with a diameter of 2 meters. And I should mention that when you are installing district cooling, then the pipes need to be larger than district heating, because what you are running them on is the difference between the forward and the return temperature. And the difference for cooling systems is simply a lot smaller. So you have to have a larger flow compared to district heating pipes. So district cooling systems, you'll have a temperature difference of maybe 10 degrees, because basically there's a limit to how cold you can send out the water. I mean, you can't get it under 0. Whereas for district heating systems, there you will have a difference 40, maybe 50 or even 60 degrees. So there you can take a lot more heat out, basically, because you have a much higher temperature difference. Coming to my conclusions, I have outlined these 4 different generations of district cooling. And we did this to kind of create a vocabulary so we can discuss district cooling, because there's a lot of talk about district cooling, but we tried to make it a little bit more systematic and provide basically these terms and this vocabulary for describing district cooling. European district cooling systems are few and relatively far apart, especially compared to district heating. And strangely enough, it's mainly in the northern part of the area. But there are plenty of development prospects, both in Europe and elsewhere. And there's a lot of work going on in the Middle East, especially within district cooling. So thank you very much for your attention. This concludes my presentation.
Right. Thank you very much, Paul. That's really great. That was really interesting.